Okay, we're back up here. We're quiet. Okay, so we're starting with the measures of central tendency, which are mean, median, mode. Okay? We've all learned this before. Who knows the song? Oh, good, a few of us. Okay. It's set to the tune of Three Blind Mice. Okay. Oh, I'm sorry. We're going to sing it, of course. I'm going to sing it. Okay. Mean, median, mode. Mean, median, mode. This is what they are. This is what they are. The mean is the one that you add and divide. The mean is the one in the middle of the line. The mode is the one that you see most of the time. Mean, median, mode. Mean, median, mode. Okay, so that is mean, median, mode. The mean is the one that you add and divide. By the number of numbers. Oh, goodness. It's now all of a sudden not letting me write there. So finish writing the word number. Numbers. And there you go. So then we're going to find the mean of this data set. We're going to add up all those numbers. So everybody add up all those numbers for me. Mm-mm. Okay, I got 216. Okay. Then you divide by the number of numbers. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 numbers.
18.
Oh, what am I doing?
18.
And we should get 18. Any questions over that? Okay, the median is the one in the middle of the line. When the numbers are in order, from least to greatest. So you have to put them in order from least to greatest. So we're going to do that right now. 14 is my first one, then 15, then 15, then 15 again, then 16, another 16, then 17, then 19, then 19 again, then 20, 21, and 29. That gets them all? Okay. Then you just start canceling them out on either side. So 1, 1, 2, 2, 3, 3, 4, 4, 5, 5.
Whoa. 17.
Very good. They're in the middle, right? Okay, to average these, you're going to take these two, 16 plus 17, and then divide them, since there's two numbers, divide them by 2. And so you should get 16.5. Is that the same as that we got for the average or the mean? No. Okay. Okay, the mode is the one you see most of the time. So which one repeats the most in here? 15. Because it's 1, 2, 3. Okay. Is that the same as any of these? Okay. You can have a bimodal data set has 2 modes. So in this case, if 16 had an extra and one more 16 with it, then it'd have the mode would be 15 and 16. Okay. Now answer these questions. Why are the measures of central tendency, that means mean, median, mode, different? And when would you use different measures of central tendency? Everyone write something down. Yep. Okay, you find them in different ways. So that's one reason, right? Okay, any other things, reasons? Okay, when would you use a different measure of central tendency? Why would we use a mode versus the mean? Any ideas? Okay, let's think about it. Most of the time we talk about averages, right? Which is the mean. But why would I not want to necessarily use an average? Okay, this class is a very good reason why I would not want to look at the class average. Okay, I would want to look at something else. Okay, I have a student that's on my roll, but they're on home hospital, but they're still on my roll, so they have a 0% in this class. Okay, having a 0% in this class would change the mean. Yes. Will it necessarily change the mode or the median? Okay. It's the lowest grade in the class, but even if it was a 50%, that'd still probably be the lowest grade in this class, right? Okay, so the fact that 0 is so low, the 0, okay, it'll affect the average of the class, but it won't necessarily affect the mode or the mean. Or sorry, not the mean, the median. Does that make sense? Okay, so that's why I wouldn't want to necessarily use our average or our mean in this class to see what the most of you guys have in the class, okay? Even in classes that don't have a 0 necessarily, but if they have, most of the people in the class have like a B or a C, but then there's like 1 or 2 students who just don't do anything, so they have like a 30% or 20% in the class. Would I want to take the average there? No, I'd want to see where most of the students fall, so I'd probably want to see either the mode or the middle, the median. Does that make sense? Okay. So when we use different measures of central tendency, I would use the median or the mode if there was an outlier, which we'll talk about later on. Outliers that really low or really high score. Okay. Or a large range. Okay. I'd want to probably use one of those rather than the average or the mean, because that will give me a clearer understanding of what most of the people have. Any questions over that? We're good? Okay. Okay, stem and leaf. Okay, the stem and leaf are the following data. The stem is the tens place value. The leaves are the ones place value. Okay. So when we do this, you're going to take the stem, and the leaf. You're going to take the 1, because we have tens, and then we have 20s. Then when the leaves are all the 1 values, so here 14, then here 15. I'm going to put them in order, because it makes it a little easier to look at. 15, 15, then I have 16, and 16, then I have 17, and 2 19s. Then I'm done with my tens values, 10. Now we're going to go on to my 20s. So that's 1, sorry, not 1, there's a 0 there, right? So I have 20, so it's a 0, then a 1, and a 29. Okay. This gives me a little understanding of where most of my data falls. Most of my data are in the tens, the teens. Okay. This, just a few are in my 20s. Does that make sense? Okay, just a different way to organize your data. And that's what we're going to be doing a lot of in this section, is just organizing my data and kind of looking at it a little bit. Okay, quartiles. I'm going to have you guys copy down the definition. It's typed pretty, so it's a little easier to look at. Okay, so there are the quartiles. The quartiles are the values that separate the data set into 4 parts. Quartile 1, quartile 2, quartile 3 are the first, second, and third quartiles. You're welcome. Okay, then a box and whisker plot is a method of displaying data using quartiles to form the box and the max and mins to form the whiskers. And I'm going to show you how to create a box and whisker. Does anyone remember doing this before? You probably did it in like 7th grade. Okay, we all have a copy down? Okay. Okay, I'm going to move on. Okay, so to create the box and whisker of the data, we want to first put the numbers, put the data values in order from smallest to biggest. So our smallest value is 81, then 85, that's a 5, then 88, then 90, then 91, 94, 95, 97, and 100. Okay, everyone with me? Now we're going to find the second, we're going to find the median of the data. We're going to find quartile 2 by finding the mean, sorry, not the mean, the median of the data. So you find the middle. You get 91. So quartile 2 is 90, not 92, but 91. Any questions over that? Then to find the median of the bottom half of the data is quartile 1. So 91 is right in the middle, so the bottom half is going to be this. Now let's just say this one had 2. It had like 90 plus and 92 was in the middle. Okay, and 91 happened to be in the, right, the average of that. You would go right in between the two. Okay, because your second quartile would be in between those two. Does that make sense? Okay, we'll show you probably one from your homework that's like this. So then you're going to do the same thing. You're going to find the median of the bottom half. So we're going to cancel out these two. And now these two are in the middle. So you're going to get 85 plus 88. And then divide it by 2 because there's two numbers. And that's going to give you 86.5. Any questions over that? Okay, now quartile 3 is going to be finding the median of the top half. So this would cancel out. And you take these two. You get 95 plus 97 and divide it by 2. And that'll give you 96. Any questions over that? Then you want to find your minimum value. Class, what's the minimum? 81. And class, what's the maximum? 100. Any questions over that? Okay. So the next thing we're going to do is draw a number line for the base of your box and whisker plot, making it sure it covers the whole data set. So let's draw on our number line. My data goes from 81 to 100, so I'm going to start at 75 here and count up by 5s. Then we'll put vertical lines above the first, second, and third quartile. So if we go back, our first quartile is at 86.5. So I'm going to draw a line there. So it's right there. Just a little bit above the 85. Okay. Then we're going to go back to quartile 2, which was 91. So draw a line above, a little bit above the 90. And then the third quartile is 96. So I'm going to draw a line a little bit above the 95. Any questions over that? Okay, then I'm going to make a box. Connect the tops of those. That's my box. Okay, then I'm going to label my maximum and minimum points. My minimum was 81 and my maximum was 100. So 81's like right about here, and 100 is right here. And I just connect those lines. That's my box doing with this. Any questions over that? Okay, now if I look at this data looks really pretty. Okay? It looks about the same distance from here to here, from quartile 1 to quartile 2, and about the same distance from here to here, from quartile 2 to quartile 3. And then from here to here is about the same as here to here. Right? This means my data is pretty evenly distributed. Okay, it has a really good data set. It has a really good average. The average is very close to the median and to the mode. Okay. It's pretty. It's good. Okay, let's look at the next one. Okay, based on this box and whisker plot, I want you to find quartile 1, quartile 2, quartile 3, the maximum and the minimum. And then write down anything that you notice about this data based on the chart. Okay. Jalen, what were your quartiles? Okay, so where does this line look like it's about? About 60? It's a little bit below 60, right? So maybe like 50, 59? Okay, what about quartile 2? 74? I'm going to say like 73. Yeah? Because it's not, I don't know, I don't think it's close enough to the 5. Okay? What about quartile 3? 83? 82? Okay. It's okay. It's about, right? We don't have exact numbers because they're not counting by ones. Okay? Let's do the max and mins then. Rachel, what's your maximum point? 94? And your minimum? Okay. Which sounds about right. Okay, what do we notice about this? Michael, what did you notice? If they're counting by 5s. Okay. Jay, what did you notice? Right? This is a lot further away than this is. So the min. From Q1, then the maxes. From Q3. So it makes this like a really much longer whisker than this one. try. Anything else you noticed? Right? The Q2 isn't like in the middle of the box. It's further away from quartile 1. It's closer to quartile 3. Okay. Kind of makes my data kind of skewed a little bit. Okay, it looks like we have these numbers are further away from these numbers. These are more closely distributed than these numbers are. Does that make sense? Okay. It makes me think that 27 might be an outlier because it's further away from the most of my data. Any questions over that? We're all good? Okay. Now a histogram. Okay, so we're going to create a histogram for the following data sets. So this is how we do a histogram. I'm going to draw a line. There we go. Let's count these by tens. So 0 to 10, we're going to have one group. Then 11 to 20, we're going to have another group. Then 21 to 30, we're going to have another group. Then 31 to 40, we'll have another group. Then 41, let me put these here, so that's a little easier. 41 to 50. Then 51 to 60. Then 61 to 70. I'm going to run out of room, so I need to make my line a little bit longer. Then 71 to 80. And then 81 to 90. And then 91 to 100. Do that. Okay, any questions over that? Okay. Okay, histograms are just a way to group things together so we can see. Histograms are often used where you don't really have numbers, or like how many red colors, how many blue colors, kind of thing with our M&Ms. So if I want to make a histogram of our M&Ms, okay, I would kind of do what we're doing here. Okay, so then you're just going to put the numbers where they fall. So there's a number that goes from here, where does 12 falls here, 17 also falls here, 20 falls here, 22 falls here, 28 falls here, 32 falls here, 37 falls here, 38 falls here, 38 falls here, 39 falls here, 41 falls here, 44 falls here, 51 falls here, 53 falls here, 59 falls here, then 62 falls here, 78 falls here, 86 falls here, and then 92 falls here. Okay. This can just show you kind of where most of your data is going to fall. Okay, and it's majority through here, through 11 to about 60 is where a majority of my data falls. Okay. This is kind of going to skew my data a little bit because they're spread out further through here. But if I look at it on the histogram, I can see, well, most people got in between, 11 to 60, whatever it is we're counting. Okay, does that make sense? Okay, again, we could use this with our M&Ms by labeling the bottoms red, blue, green, yellow, brown, orange, and then putting little X's where our different numbers spell, or different colors spell. Does that make sense? Okay. Okay, what do you notice about the data set? We kind of already talked about it. Most of my data (31 through 40) had the most numbers. Does that make sense? Okay. Any questions over that? All good? Okay, percentiles. Let me give you that definition. Okay, divides the data into 100 equal parts, where the percentile of a given value is determined by the percentage of the values that are smaller than that value. For example, a test score that is greater than 95% of the other scores is in the 95th percentile. Okay, we're going to move on. Okay, we're going to try the 20th and 80th percentiles for the following data set. You guys are very familiar with percentiles because when we had the old STAR testing, you'd get the data at home and it would tell you the percentile that you're in. Okay? Standardized tests are not like a given. If you get 25 out of 30 correct, you have this percentage, and you just divide it, find the percentage. It's how you do and compared to everybody else who took it at the same time. Okay? So that's why they do it in percentiles. So they put everybody's score in this big long line, okay, and then they calculate the percentiles. Okay, and we'll show you how to do that. So that just tells you how you did compared to everybody else. Okay, so it just depends on how smart everyone who took it when you are. That's the same with the bar. Okay, do you know what the bar is? Bar is when you want to pass the bars to become a lawyer. You have to go to school, get your, I think it's a doctorate in law, and then before you can come be a lawyer, you have to pass the bar. Okay, and again, they only take a percentage of the people who took it at that time. So if you took it where everyone's really smart, or there's a lot more people, you have a lower chances of passing it. Okay. So here's percentiles. Because it's a standardized test, and they only take the top however many. So we want to put these in order from least to greatest. Are they? Yes. Okay, good. 32, 37, 38, 41, yes. They're in order. Okay. To find the 20th percentile, multiply the number of numbers by 0.20. So how many numbers are there? Okay, there's 20 numbers. So we're going to take our 20 numbers and we're going to multiply it by the 0.2. And we should get 4. Okay. Then count 4 numbers and go 1 above it. So we're going to count 1, 2, 3, 4, and the 1 above it is the 20th percentile. So 22 is the 20th percentile. So you would need to score a 22 in order to be considered in the 20th percentile, because that means you are better than 20% of the people who took it at this time. Does that make sense? Okay. Now let's do the same thing with the 80th percentile. So you're going to do 20. What am I going to multiply the 20 by this time? 0.8. And that should give you 16. Any questions over that? Then we're going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and then 1 above. Okay. Any questions over that? So 86 is the 80th percentile. Any questions about that? We're all good? One more page. You guys are doing great. Okay, so the outlier, oh goodness. Now we get our definition. Is a data value that is extreme compared to the rest of the data set. Outliers can pull the mean down if it's a small value, or pull the mean up if it's a larger value. So right here is a data value that is extreme compared to the rest of the data set. Outliers can pull the mean down if it's a small value, or pull the mean up if it's a large value. are we good? Okay. The range then is how spread out your data is. Okay, so for here, what would we consider the outlier, class? 3. Okay, it's a lot smaller than the rest of the data. The range then, you just take the smallest number, and then which one's the largest? 42. So 42 minus 3 gives me a range of 39. So the distance between all the numbers is 39. Okay, which is kind of deceiving, right? Because where does most of my data fall? 30s, right, and a couple 40s. So really the data is only kind of spread out between about 10. But that outlier throws out the range as well. Look at this one. Where's my outlier? 78. Okay. Then our range is going to be, what's my smallest? 43. Well, let's make sure we have positives.